All right, so let's talk about, first of all, we're going to talk about vertical angles, right? So let's suppose we have two lines that intersect together, right? So we have two lines, right? We go like this, right? And they intersect, right? And they intersect at a point, right? So we have this angle over here, right? We have this angle over here and this angle over here, right? So what are these two angles called, right? Like if they intersect and they have two angles that are kind of opposite to each other, right? What are those two angles called? Vertical angles, right? Right. So what do we know about vertical angles? Okay, so they're across from each other. What do we? If I know that this one is 35 degrees, what do I know about the other one? So it's also 35 degrees, right? Let me ask you a question. How much is this angle over here? How do I forget how much is this angle over here? Yeah, 35 and 35. All right. What is 35 plus 35? Right. So is this one going to be 70? Not sure, right? So let me ask you a question, right? So this angle over here, right? What is this angle plus this angle, right? If I say this over here is angle A, right? Angle A plus 35 should equal how much, right? Do you notice anything from the picture? Angle A and 35. Together they equal how much? 180, right? Because together, see, if I block out this portion here, right? Together they form like 180, right? Together they form a line, right? So how do I figure out angle A now? So you subtract, right? 180 minus 35, and you get your answer. Does that make sense? All right. So basically, that's those are vertical angles, right? So our first theorem, right? Remember we were talking about like doing proofs, right? So our first theorem is that vertical angles are congruent. Vertical angles are congruent, right? So this is just telling you that if you have two vertical angles, that they're congruent. So we're gonna do like a proof later on, so you'll see like how a two-column proof works, right? But so our first theorem is that vertical angles are congruent. We have two vertical angles, they're going to be the same, right? So this kind of information we're going to kind of like keep in our mind, right? These theorems, these are things that we can use to prove other things, right? Next one. All right. So if we have a theorem, right? What does this word theorem mean, right? If I say that vertical angles are congruent is a theorem, right? What does that mean that it's a theorem? Not a theory. It's basically like a statement that we can prove, right? We can prove that this is true, right? So do you know what is the difference between like a theorem and a postulate, right? I think in one of the previous lessons we looked at this one, right? Theorem versus postulate. What does postulate mean? Mm-hmm. So postulate is like is something that we don't have to necessarily prove, right? So a theorem is something that you have to prove, right? So this statement here, vertical angles are congruent. I can't just say the statement, right? I have to prove that it is true, right? I have to prove that this statement is true. Okay. All right. So let's try to prove it. So I have, right. So I'm going to do a two-column proof. All right. We're going to do like a two-column proof like this. Right. On the left are like my statements. 1, 2, 3, 4. I'm making statements, and on the right is like my reason for each one. 1, 2, 3, 4, like that. These are like my reasons for each one. Right. So over here, these are my statements, and these are my like my reasons. All right. All right. So let's go over here. Right. Let's suppose I have I have two vertical angles. Let's say this is A, this is point B, this is point C, this is point D, this is point E, right? So let's suppose I have this angle over here, right? ACB, right? So this angle over here what is the name of this angle over here? Right, AC, right? I start here, ACB, right? What is the name of this angle over here? How would I say this angle over here? BCE, right? Right. So I say that, you know, ACB and angle BCE, right? What do I know about these two angles put together? Right. If I add these two angles together, what are they going to be equal to? You're right. So ACE, right? And how much is ACE? How many degrees is ACE? 180, right? Okay. So this is my first statement. I'm first saying that, okay, these two together equal 180, right? Now I need a reason, right? What is going to be my reason for this? Like, how do I know that this is the case like this? Right. So they are like linear pair, right? So my reason, the reason that I'm going to write here is definition of supplementary angles. Right. What are two? If I say two angles are supplementary, what does that mean? Definition of supplementary angles is equal to 180, right? All right. So next, I'm going to go down here, this angle over here, right? Angle DCE, right? Now, DCE plus ECB is how much? How much are these two angles going to be? Also 180, right? You see how those are like the same kind of thing, right? You see how this angle over here, I can kind of pair it with this angle, right, to make 180, right? See how I compare these two together? And I can pair these two together, right? I could take this angle and pair with either one of those, and it's going to form 180. Does that make sense? So what do you think? What do you think is kind of like what are we trying to get at? Can you kind of predict, like, what are we trying to get at? Okay, I'm saying that this angle I could pair with this one and make 180, or I could pair it with this one and make 180. So what do you think I'm trying to get at? Right, they're kind of like interchangeable, right? Because if either of them can pair with this one to form 180, and this one doesn't change, right? This is equal to itself. Then these two must be kind of like the same kind of thing, right? They're interchangeable. You understand? So, but do you notice how so like logically you can kind of figure it out, like what's going on, right? But so try to connect that with like how we're writing it out step by step. You understand what I'm saying, right? So this is the same thing, right? I'm saying the same thing. Definition of supplementary angles, right? So this reasoning is the same, right? All right. What do you think could be like the next step, right? So I got these two statements. Mathematically, how would I write out kind of like the next step, right, in our logical process? So here's what I'm going to write out. So ACB plus BCE equals okay. So I'm saying ACB plus BCE, right? These two angles equals these two angles, right? How did I get that? How did I get that these two angles are equal to these two angles from like the statements above? So what I'm saying is that these two angles here, right, are equal to these two angles down here, right? These two angles are equal to these two angles, right? How did I get this statement here from these statements above? Right, these two are equal to 180. This is also equal to 180, right? do you know? So what is kind of like the mathematical reason for saying that? Okay, therefore these two angles are equal to these two angles. Right. So it's called substitution. Right. So what is that? What does that mean? Substitution. Like how did I substitute one thing for another? What's going on here? Right. So like if this is equal to 180 and this is equal to 180, right? Like so, the 180 in this one, right, is equal to these two angles. So I can take these two angles and put them in the place of this 180 here. Right. All right. So from here, here's what we're aiming for, right? I'm trying to say that this angle over here is equal to this angle over here, right? So ACB. I'm trying to say that this angle over here is equal to this angle over here, right? So I'm close, but I'm not quite at that step. All right, so what do you think I can do next? Like, what's kind of like the next step over here? Right, because I want to say like ACB equals DCE, right? That's kind of what I want. I want a statement ACB equals DCE, right? That's kind of like that simple statement that I want. So how can I go from this step over here to that step? Not sure, right? So what do you notice about this angle over here? So there's with those angles that I want to keep, there's like this angle over here that I want to get rid of, right? BCE or ECB, it's the same thing, right? So I can just subtract that angle out, right? Right? I can, if I subtract that angle out, what do I have left? I just have ACB equals angle DCE. Right? And what is my reasoning like? What was the thing that I used? How did I just get this statement from here? Right. So what did I do? I subtracted them out, right? So subtraction property of equality. Right? Remember, I think we talked about that before, right? Remember, it just means that the same, right? If you have two things, if I subtract something from both sides, that's okay, right? Like just like I can add something as long as I add it to both sides of an equation, right? So I'm subtracting this from both sides of the equation, so that's okay. I can do that. That's called subtraction property of equality, and this is what I have left. Right? So I know that these two are equal to each other, these two angles. Right? So if their measurements are equal, right, then we can say they're congruent, right? Right? If their measurements are the same, then I can say that they're congruent. So what I can do is like the next step, what I can do is I can put this. I can use this symbol like this. Right? This angle is congruent to this angle. And I can put definition of congruence, right? Because if the measurements of two angles are the same, then they're congruent. That's what congruence means. Okay, let me ask you a question. Do you understand do you understand the logic of how this works? Not necessarily like memorizing each steps and the reasons, but like overall like how like logically we kind of figured out how to prove that this angle is equal to this angle. Just like the logic makes sense. Right, right. So these are our reasonings, right? So they could be in our reasonings, right? We could have postulates or theorems. But overall, what we're trying to prove is a theorem, right? I'm not talking about necessarily that. I'm talking about like, do you understand like like how we like added these angles together and saw that, okay, if I subtract this angle out, then I'm left with these two angles, and so they must be right. So that's the most important step, right? Because once you figure out like the logic, if you understand like why these two angles are the same, well, then just like writing it down step by step becomes a lot easier, right? That just takes practice, right? Just taking practice, like how do I write these things down in like a mathematical step by step manner? That just takes practice, right? But if you understand like the approach, like, okay, how do we, how do we decide, what to do? That's like the most important thing, right? So what is the idea, right? So we have these two angles here, and we figured out, okay, if I add this angle 1 to this angle, or angle 2 to this angle, they both make 180. So if I subtract out this angle, then 1 must be equal to 2, right? 1 and 2 are interchangeable. Because if you add either of them to this third angle here, they make 180, so they must be the same. That's kind of the logic of it, right? All right. So if you understand that, then the next step, like writing it down and stuff, then that becomes like much easier, right? This one here. All right. So let's take a look at parallel lines cut by a transversal, right? So let's suppose I have two lines that are parallel, right? Like, what does that mean? If I say that these two lines are parallel, like, what does that mean? Right, right, exactly. Right. So they're going in kind of like the same direction. They have the same slope, right? They never intersect. Okay. Now I'm going to have another line that kind of cuts both of them like this. Okay, so I'm going to draw a line. So it's going to cut both of them. So this line right here is called a transversal line. All right. So this line over here, this line I'm going to call it a transversal line. All right. So around each, do you notice like where each of these transversals cuts the parallel line, you're going to form basically 4 different angles, right? 1, 2, 3, 4, 5, 6, 7, 8. You notice that, right? There's basically 8 angles total that are going to be formed, right? So these angles, they have different kinds of relationships, right? Let me ask a question. What is the relationship between angle 2 and angle 4? They're vertical angles, right? So angles 2 and 4 are what? Like, what do we know about their angle measurements? They're the same, right? What about angle 5 and angle 7? They're also the same, right? So vertical angles we've already talked about a little bit, right? All right. Now let's talk about alternate exterior angles. So there's a couple of angle relationships, right? We have something called alternate exterior angles. All right. Do you know what that means? Have you heard of that term before? Alternate exterior? Not sure. So first of all, it says exterior, right? So exterior means on the outside, right? So exterior angles are going to be these ones down here, 7 and 8, and these ones up here, 1 and 2. Why do you think these ones over here and over here are called exterior angles? They're on the outside, right? What do you think 3 and 4 and 6 and 5 are going to be called? Interior angles, okay? Now, 2 and 8, okay? You notice 2 and 8. What's the relationship between 2 and 8 in comparison to this transversal line? Are they on the same side or opposite side? Opposite side, right? So if they're on the opposite side, they're called alternate angles. Right? So let's look at angle 2 and angle 8. They are alternate because they're on opposite sides of the transversal, and they're exterior. They're on the outside. Does that make sense? Right? So they're called alternate exterior angles. Right? What do you think is the relationship between alternate exterior angles, 2 and 8? What do you think is like the relationship between the angle measures? So what is the relationship between angles 2 and 8 in terms of their measurements? So they're going to be congruent. They're going to be the same measurement. If this is 120 degrees, this is going to be 120 degrees, right? So alternate exterior angles are going to be congruent, right? Now, what about same side exterior angles? Can you give, maybe take a look at this, right? Same side exterior. Can you give me an example of some same side exterior angles? Right? So remember, first of all, exterior, right? So they all have to be exterior angles. So one is exterior, okay? I want two angles that are same side exterior. So one and right? So remember, so those would be alternate, right? Because 1 and 7 are on opposite sides, right and left of this transversal line. So 1 and 8. Okay. So 1 and 8 would be same side exterior angles. Right? Right? So 1 and 8 would be same side, right? So they're not alternate, right? So alternate means on opposite sides of the transversal. Same side means on the same side, right? So 1 and 8 are on the same side over there on the right side, and they're exterior, right? You see how they're on the outside? Right? So those are called same side exterior angles, right? Can you name another pair of same side exterior angles? 2 and 7, right? What is the relationship? Remember we said alternate exterior. These ones are going to be like congruent to each other, right? What about same side exterior? What is going to be the relationship between 1 and 8 or 2 and 7? So they're going to add up to 180. They're going to be supplementary, right? Because so, if you look at the picture, right, can you kind of notice one is a little bit smaller than 90 degrees, right? But this one down here is a little bit bigger than 90 degrees. So this one is smaller, right? You notice that one is a little bit smaller. This one is a little bit bigger, right? So together they add up to 180. Right, so we're gonna talk about 4 and 5, right? All right. So what about this one? Alternate interior angles. All right. Take a look at this one. Can you name for me a pair of alternate interior angles? 3 and 5, right? What's another pair? 4 and 6, right? All right. So what's going to be their relationship? Congruent or 180? Not 180, right? You notice 3 is a little bit smaller than 90 degrees, and 5 is also a little bit smaller than 90 degrees, right? So if they're both smaller than 90 degrees, they can't add up to 180, right? So these are going to be congruent. Right? So 3 and 5 are going to be equal. 4 and 6 are going to be equal, like this, right? And what is the last one? Same side interior. Can you name for me a pair of same side interior angles? 3 and 6 and 4 and 5. Okay. Right. So 3 and 6 and 4 and 5. Right. So what is going to be the relationship between 3 and 6 and 4 and 5? They're going to add to 180. So you notice that 3 is like a little bit smaller than 90, right? But 6 is a little bit bigger. So together, they're going to add up to 180 together. Does that make sense? All right. Let's go to, right. So now how about 2 and 3? What are 2 and 3 going to add up to?
Oh, it's not cool.
No, it's not. So 180, right? So 2 and 3, they form a straight line, so they're going to add up to 180, right? Right. Let's go to the next page. All right. So if we take a look over here, right? Right. So do you notice, like in here, 1, 2, 3, 4, 5, 6, 7, 8, right? What do you think? Do you notice that, so angle 1, right? Among these 4 angles, how would you describe the location of angle 1? Like, where would you say angle 1 is?
It's congruent to angle 3.
It's the top right, right? Over here, what is kind of like the top right angle in this one? Angle 5, right? So you see how angle 1 and angle 5 are kind of like in the same position in the 2 levels, right? Okay. Can you name some other sets like that? So 1 and 5, and then what else? 3 and 7. Okay, Ismail, can you name 2 other?
2 and
set?
6,
Okay.
4 and 8.
Right, so 2 and 6, and 4 and 8, right? You see how those are all in like the same place in the 2 different levels, right? So those pairs, like 1 and 5, okay, 1 and angle 5, angle 2 and angle 6, and so on, right? These different sets together, these are called corresponding angles. Right? So these corresponding angles, okay, they're basically kind of like in the same location, right? What can you tell me about the angle measurements of corresponding angles, right? Angle 1 and angle 5, are they supplementary? They add up to 180, or are they congruent? Ismail, what do you think?
Wait, can you repeat that? What happened?
So corresponding angles, what can you tell me about the angle measurements of corresponding angles? What is the relationship among the angles?
Basically, they're the same.
They're basically the same, right? So if I have some corresponding angles, they're going to be the same. So 4 and 8 are going to be the same. 3 and 7 are going to be the same. 2 and 6, 1 and 5, all those pairs are going to be the same. Okay, does that kind of make sense?
Mm-hmm.
So they kind of look the same, right? They kind of look the same, and you can kind of tell intuitively that they are the same, but they are the same, right? So here's what we're going to do. The first thing we're going to do is we're going to prove that these two are the same, right? So corresponding angles, right? We're going to prove that they're the same. So let's do like a 2-column proof for corresponding angles. Right, so I'm going to draw this one again over here on this side. Right? So I have 2 sets of parallel lines, right? Remember? And then I have this diagonal line that kind of goes through it. 1, 2, 3, 4, 5, 6, 7, 8. Right? So for example, what I'm trying to prove is that angle 1 and angle 5 are the same, right? I want to prove that this angle over here and this angle over here are congruent, right? That's kind of what I want to end up doing, right? So I'm going to do like a 2-column proof over here. All right. All right. So first of all, I'm going to write down like the different things that I know, right? So I know that these 2 lines, let's call it line L and line M, right? So I know that these 2 lines, lines L and line M, are parallel to each other. So I'm going to write that down. I'm going to put line L
Wait, so are you basically reviewing the lesson?
Yeah.
Oh,
Okay. I'm going to say that those two are parallel, right? But you guys,
yeah.
do you recognize like the symbol soda for parallel?
Yeah, yeah.
Right? It's like the two lines, right? It's parallel, right? So what is my reasoning there going to be? What do you think my reasoning there is going to be?
They're no, what do you say? Corresponding. I know.
So first, just the first statement. Lines L
Given,
and lines M are
given,
parallel.
given.
Given, right? What does given mean? Spell. What does given mean?
Basically, it's like what's your given, like in a question, like in the
Right. So,
test.
so they tell it to you, right? So it's not something we got to figure out. They're telling us that these two lines are parallel and they're cut by a transversal. They're giving us that information. That's what's given.
Mhm.
Okay. All right. Now here's what I also know. I also know that this whole line 1 plus 4. Okay. I know that 1 plus 4 equals 180. Okay. All right. So how do I know that? How do I know that angle 1 and angle 4 equals to 180? Ismail, what do you think?
Equals to one. Because they are linear pairs.
Yeah, so they're linear pairs. What is the reason that I would write over here?
Angle 1 and angle 4 are linear pairs.
Linear pairs.
Oh no, do you write substitute?
Something like that. So you could write that they are angle 1 plus angle 4 together. They are a linear pair, but it's officially called definition of supplementary angles. Right? So you could write that these are supplementary angles.
Scott, you're lagging.
Okay, can you hear me?
You're lagging. You're lagging for me. Like when you do something, am I lagging or?
No, I don't think so. I don't hear it lagging.
Okay, I think you're good now. Wave your hand.
All right, can you see?
Still kind of laggy, but it's okay.
Okay. All right, so angle 1 and angle 4, right, equals 180, right? So
Uh-huh.
definition of supplementary angles, right? Now, I also know that angle 4 plus angle 5, right? Let's take a look at this one. Angle 4 plus angle 5. How much is angle 4 and angle 5 together? Soda. How much would be these two angles? Angle 4 and angle 5. These two together would be how much together? 180, right? So how do I know that? Like what is the relationship between those two angles? So remember, do you remember those names we were talking about? Alternate, same side, exterior, interior, all those things, right? What is like? So what do we call these two together? Corresponding, not corresponding. So corresponding would be like 1 and 5. I'm talking about this one right here. These two right here.
Those are.
So are they on the same side or alternate sides of this transversal?
Isn't that the interior one?
So they're interior. So they're same side interior. Let's examine this. Same side interior angles theorem. So this theorem tells us that if we have same side interior angles, they add up to 180. So again, so same side, what does that mean? You see the transversal line, right? They're both on the right side, right?
Yeah.
Right, so that's called same side. If one was on the left, another was on the right, then it could be alternate. If they're both on the right side, it's called same side. Now, so why is it called interior angles? Oh, so because they're both inside the parallel lines, right? If it's outside the parallel lines, we call it exterior. If they're both inside, we call it interior, right? So the same side interior angles theorem tells us that together they're going to add up to 180. All right. So these two together add up to 180. All right. So, what am I going to do next? Can anyone take a look at what I have on the board here right now? And what can I do? What can I do next? Because what am I trying to aim for? I'm trying to aim for angle 1 is equal to angle 5. Right? Remember, we always have to keep our goal in mind. Okay. So take a look at this here. Can anyone kind of predict like where are we going? What's the next kind of step or thing to do?
Angle 2 plus angle, no, angle 2 plus angle 3 is 180?
We could do that. Is there something similar? How about something based on just what we have already? What if we don't use any more angles? We have
Now we add it up, I think?
Add it up, kind of.
Or substitution or something like that. I don't know.
Right, so then what do you think? What do we do? Right. So that what do you think is like the next step that we do over here? Any ideas? You're not sure. So something like that, right? Okay, so some kind of substitution, right? So what are we going to substitute? Oh yeah, I think the camera is not the best camera. Right, so this says angle 1 plus angle 4 equals 180. Angle 4 plus angle 5 equals 180. So what can we substitute here?
Angle.
Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8.
Oh, we could substitute angle 5 for 4 because they're basically this.
Okay.
Or no, or
so angle 1 plus angle 4 equals angle 4 plus angle 5. Right?
Oh, is that right?
Is that what you guys were saying?
Yeah, sort of.
Right?
Something like that.
Because they're both equal to 180, right? Right? This pair together is equal to 180. This pair together equal to 180. So these two pairs are then equal to each other. Right?
Yeah, I see.
Right? Like if this is like this 180, right? I know 180 is also equal to this. So therefore this I can put in place of 180 here. Yes. Okay. So I think that's what you guys are saying, right? Right.
Mm-hmm.
So now I know angle 1 plus 4 is equal to angle 4 plus 5. All right. Okay. All right. So after you remember, you guys said substitution, right?
Mm-hmm.
All right. So what is the next step? Again, check the goal. What are we trying to do next?
Then we're gonna. Maybe then we do.
So what if I do this?
We add it maybe.
So what if I subtract angle 4 from both sides? What's going to be left if I subtract angle 4 from both sides?
Angle 1 equals angle 5. Ooh, and that's what we're looking for.
See that? The measure of angle 1 is equal to the measure of angle 5. Right? Because you see angle 4 is on both sides now, right? So I can subtract that both out. What is my reasoning? How was I able to do that? What is my reason that I'm going to write here?
Distributive combine like that.
Distributive property. So subtraction property of equality. So that's a fancy way of just saying that you can subtract, like in an equation, right? If I subtract 5 from one side, I can do that as long as I'm doing to both sides, right? So that's all this means. Subtraction property of equality.
Wait, Dr. Yahi, are you coming this weekend on Saturday?
Oh, to the voting thing? No, I don't think so. Wait, you guys are going on the boat, right?
Yeah.
No, not on the boat. All right.
Okay.
So that's what subtraction means. So it's the same thing for all of them, right? There's addition, subtraction, multiplication, division. It's all the same kind of thing, right? They're all the same. They're all the same idea, right? If you do something to one side of an equation, you could do something to the other side of the equation. It's all the same thing, right? So measure of angle 1 is measure of angle 5. Now from here, right? We're talking. So actually, technically, over here on all of these, I should put m. see, I'm going to put next to all the angles, I'm going to put M. M stands for measure. That means like the measure is like the number of degrees, right? So technically next to all these angles, I should put like a little M of all these angles. Now the next step, I'm going to put this. I'm going to change it into this. Angle 1 is congruent to angle 5. You see the symbol congruence? I'm going to add this as the last step, right? Because if the measure of two angles is the same, that means that they're congruent. So this is called definition of congruence. All right, let me ask you, Ismail, do you understand the logic of what we did here, right? So I did, look, these two angles are the same. I mean, I'm sorry, these two angles add up to 180. And I know these two angles add up to 180. So therefore, these two angles up over here, right? If I know 1 and 4 add up to 180, right? I'm saying, look, I know 1 and 4 add up to 180. And I know 4 and 5 add up to 180. Therefore, angle 1 and angle 1 plus 4 should be equal to angle 4 plus 5.
Ustad, this is just like to explain because we always know that 1 and 5 are going to be equal because they're corresponding, right?
Right. So this is to prove that that's the case. We're trying to like mathematically prove that that's the case, right? So we have to write it out in all this detail. Okay. But do you understand like the logic first, right? If you understand the logic, then it's just practice to write it down in a disciplined step-by-step manner. But do you understand like the logic of like what we did?
Yeah.
Okay, you're right. So that's, if you understand that, then it's just practicing, just writing down, making sure you remember each of these theorems. You got to just like sit down and just try to like remember, memorize the names of these theorems, right? But you guys understand what this means, subtraction, property of equality, right? You guys understand what that means. Substitution, right? I think you guys got that. These things, right? It's just, if you understand the logic of like the overall picture of how our strategy, then you just got to like practice and memorize how to write this stuff down, right? So it just takes a little bit of practice. But if you understand the logic, like how this works, then that's the most important first step, right? Let me look at the next one. All right. So now let's do this one over here, right? So we're going to prove the alternate interior angle theorem, right? So this was the corresponding angles, right? Remember we said 1 and 5 are like corresponding angles. So we showed that, yes, corresponding angles are congruent, right? So now we're going to prove alternate interior angles. Right. So let's look at it. We have these two lines. Maybe cut by this transversal like this, right? So again, these two are parallel lines, right? So I'm going to put a little parallel symbol like this here. Okay. So I know that this is 1, 2, 3, 4, 5, 6, 7, 8. All right. I think you guys can see that. Okay. All right. So, can you name some alternate interior angles? I'm looking for alternate interior angles. Okay, so let's go with 3 and 5. So I'm going to try to prove that angle 3 is congruent to angle 5. Does that make sense? Right? That's my goal, right? We always got to keep our end goal in mind. That's what I'm trying to get to. Okay. So let's go over here. All right. So angle 3 and angle 5, right? So there's different ways of proving it. All right, let's take a look. So, all right.
Angle 3 is
all right, so here's one way we can do it, right? So, all right, so anyone have a strategy, right? Anyone have any ideas about?
Yes.
All right, Ismail, tell me like a strategy. What kind of approach could you take?
Well, I think we should do first that line. The two lines are parallel.
Okay, all right. So let's write down lines L. Are parallel, and that's given, right?
And I think we're
but
I'm
not talking about the specific steps. I'm talking about just like an overall general strategy.
Maybe the 3 and 6 interior angle. I mean interior.
Okay, so these are same
side.
Okay,
those
so, all right, and then what do we do next? Like, why are we going to do that?
because then we're gonna do maybe 6 and 5. I don't
Okay.
know.
6 and 5. Okay, so that's actually a good way, right? So here's what he's saying, right? He's saying, look, 3 and 6, we say, oh, these add up to 180, right? And then
Yep,
how much do 6 and 5 add up to?
180.
180. So therefore, 3 and 5 are going to be kind of the same, right?
Yeah.
Right. Here's another way. So here's the way that we're going to do it, right? 3 and 1. So what is the relationship between 3 and 1? So are they the same? Add up to 180? What are they?
Someone called, I forgot.
They're the same, right? So you see 3 and 1 are the same. Now, Ismail, 1 and 5. What is the relationship between 1 and 5?
Corresponding.
Corresponding and therefore?
They're the same.
They're the same, right? So 3 is the same as 1, and 1 is the same as 5. Therefore, 3 is
5.
same as 5. So do you guys understand? Like, before I even write stuff down, I got to have like some kind of strategy in my mind how I'm going to get where I'm trying to get. You guys understand, right?
Oh no.
So it
Yeah.
just takes practice to do it, right? But you see how I'm trying to like work out what is the approach that we want to take before I'm even writing anything down. Okay, so let's go and do that. So angle 3, here's what I'm going to put the measure of angle 3 is equal to the measure of angle 1, right? So that what is my reason? How do I know 3 is the same as 1? What is my reasoning?
What's that thing called?
Or just a second.
Adjacent angles, I think.
Adjacent angles? Not quite adjacent. There's
Not
something-
adjacent.
So what is it? Vertical angles, right?
Oh yeah, that's what it is.
Good. All right. So what was the next step? So we said 3 is equal to 1. What else? What else did I see?
That one is also corresponding to 5.
So the next thing I want to see is that 1 is the measure of 1 is 5. And what reason am I going to put Ismail over here? The
Corresponding
corresponding angles theorem.
angles.
These are called theorems, right? Corresponding angles theorem, vertical angles theorem. All right. So then what is the next step I'm going to do? Substitution, right? So what am I going to write down here for the next step? Like this, right? Because if I know that, because if 1 is equal to 5 and 1 is equal to 3, then I can take my 5 and stick it in this place, right? So you can use substitution. And then what is going to be the final step? Because we're almost there. Congruence, right? So here, you see this little m? This just means measure. The measure of angle 3 means like it's degrees, right? So the measure of this is equal to the measure of that, and therefore they are congruent. So you see, I just like changed the symbol a little bit. Okay, and I'm no longer writing the measure. I'm just saying this angle is congruent to this angle. So that's called definition of congruence. Okay. I think this one you guys understood the logic pretty well, right? You guys understand, right? So that's the thing, right? Before I start writing all this step down, step one, step 2, working it out, I have to have an overall strategy in your mind. Okay, so you got to be familiar with these angles and
What do you mean by substitution for 3 and 5? Why is this?
So here's what it means, right? So what is angle 1 equal to? What is the measure?
Oh, so you're basically substituting 3 for 1, right?
Right. I'm taking this and I'm substituting in over here.
Oh.
I'm replacing that because I know from the second statement that 1 is the same as 5, right? So for this one, I'm just going to stick 5 in its place. Substitution.
Yeah.
Right. So the idea is that overall, you got to have the general strategy first in a proof before you write it down. Like try to like come like before you start writing anything down, just look at the picture and come up with your own ideas first before you're going step by step and writing it down. Right. I don't think we did subtraction here. Because in the last one, what we had an equation where on both sides there were like two angles. Right? There were like two angles on both sides. Yes. Yeah, because we had like two angles add up to 180, right? So that was a substitution that we did. Right? All right. So, all right. So I think that's it for the lesson in terms of stuff. The rest is practice. Let's take a look.
I did my test. I got an 80 though.
Where I did it. Okay.
With me. Yeah, remember you said that I do it and then
Mhm.
I reset it. I'm gonna try resetting it.
Okay. All right. So here's what I want you guys to do. Go to page 8. All right. So I want you guys to go to page 8 and go ahead and start doing the practice right now. There's like there's like I think 1 or 2 questions here. Wait, how many questions are there? Question 1. Okay, yeah. There's like 4 or 5 questions, right? So I want you guys to go ahead and start doing this practice now for like the next like 5-6 minutes. All right. So do you want to start doing the practice on page 8?
Rip me Ustad, why?
Oh yeah, Islamic studies. Okay. Oh, okay. All right. So yeah. So